Today's topic is under marine electrical, main switchboard safeties and protection. So we'll see the picture of main switchboard. This is main switchboard. Before we go for the special safeties, we have general safeties, that is personal protective equipment safety. So that general safety is like insulated rubber gloves, dry boiler suits, shoes, helmet. So these things will come under the general safeties. So generally, safeties are for human being as well as for the machineries. So for the lifespan of the machineries, for the lifespan of the main switchboard, also for against the shock for the human being. So what are the special safeties? The special safeties, first point is the MSB should be installed on raised platform. So to avoid rough sea or rainy season condition or under the flood condition, so the water should not enter into the MSB board. So it should be in a raised platform with good ventilation, proper ventilation and lighting system. So and less vibration on board ship. The vibration should be also less. So that will be the selected area to install MSB board. That will be more safe for the main switchboard. So we have dead front panel type. So more than 50 volt, we use dead front panel type. The meaning is all the live conductors will be passing behind the MSB. Only the meters, instrumentation meters, indicators, synchronization indicating lamp, frequency meter, voltmeter, ammeter. The meters will be present in the panel board. All the live conductors will be passing behind the MSB. So this is the most important safety. And next is ebonite rod to remove the static charge. Ebonite rod to remove the static charge. So this I have shown in the picture. So this is the ebonite rod. So this rod is made up of a hard rubber. So what is the static charge, where it is found? The static charge, when the liquid is moving inside the wall of a pipe, a static charge can be found. That is, whenever the two surfaces are in relative motion, a charge is produced. When we sit in a chair and we get up from the chair, there will be some attraction of charge. So when we use this fire extinguisher, carbon dioxide, sometimes people may get some mild electric shock. That is also due to some static charge. When a solid particles is moving in the air, there also some static charge. So on board ship, mainly in the cargo tanks, because of the movement of the liquid inside the tank, static charge can be formed. And while cleaning the tank, static charge can be formed due to the water forced in a pressure. Static charge can be formed. So static charge is nothing but the electrons which is revolving at the outermost orbit. It starts to exchange itself. So there will be some excess amount of electron, or there may be some deficiency of electron. So this imbalance of the electrons, the imbalance of the charge, so that is said to be a static charge, which is present stationary at a point. So which is very dangerous. So this may lead to spark, ignition, and explosion also. It is very dangerous one. So what this ebonite rod is doing, this hard rubber is doing, it is observing the charges. It observes the charge and it does not discharges. It does not dissipate. It keeps for itself. And that way it is protecting the human being as well as the missionaries, as well as the MSB board. So this is also one of important point for the safety of MSB. Next is no water, steam, oil pipe. Oil pipe should pass above the switchboard. So water or conducting material. So this type of things should not pass near to the vicinity of the switchboard. So should be properly installed where proper ventilation, proper lighting system is available, and there should not be any pipelining. So this during the installation, We have to look on that. So there must be panel doors and equipment should be properly earthed. So this will give the extra safety to the devices. The panel boards are earthed. The operating floor space, the space around that MSB, the rubber mat, insulated rubber mat should be a minimum thickness of 15 mm. So that type of rubber mat will be placed here. The rubber mat will be placed here. So here will be a rubber mat just of 15 mm thickness. So next is incoming and outgoing feeder must be protected by a switch, fuse or circuit breaker. So these are all the protecting devices which is present in the MSB: fuse, circuit breaker, reverse power relay trip, preferential relay trip, overcurrent, overloaded, and low frequency trip. So these trip circuits or relays and trip circuits are called as that is safety devices which is present in the MSB. So earth fault indicator lamp, insulation meter that should be fitted in the front panel. Earth fault indicator lamp or insulation meter should be fitted. The insulation is measured by using Megger, and that should be not less than 1 mega ohms. So these meters are fitted in the front panel, ohm meter and this. Next, the door opening should be interlocked with the power supply. So whenever we open the door, there should not be power supply. But if by mistake, if you are opening the door without tripping the supply, automatic trip will be there. That is interlocked with the power supply. Automatically, it will trip off. And there should be 0.6 meter gap behind the switchboard. So I'll show the diagram here. So this is switchboard. Here we have 0.6 meter gap between the switchboard. So if any arcing or arc blasting, that should not defect the other boards. So that should not develop the fire or explosion further. So there should be always gap and proper ventilation should be there. And the MSB board also, it is made up of a separate cubicle, stainless steel cubicle, so that the spark should not develop to the other side. So it is kept in the 0.6 meter gap. So arc blasting is very high temperature. So this should not happen. And all components, that is switches, gauges, meter, fuse, push button, circuit breakers, indicating lamp, should be in a working condition and must be identified with the name tag. So switches, what type of switches? We have a single pole, double throw switch, double pole, single throw switch. Different types of switches are there. Different types of fuses are there. And whether it is an analog meter or digital meter, what type of meter, what is the range, and push button. So everything has to be put with the name tag. What is its working condition and what is that? So that has to be put with the name tag. If it is a high voltage system, then you have to put a red tag showing a danger. Next point is the enclosure should be drip proof. That is a waterproof, liquid proof, any liquid should be proof. With that, the continuous insulation monitoring will be present in that. We have to monitor the insulation and it should not be less than 1 mega ohm, as I have already mentioned. And portable CO2 extinguisher placed nearby the MSB. So for any emergency. So this is a red tag. A red tag is used for danger sign, that is also fitted for an high voltage system. Normal high voltage cables will be always having some charged charges with them. So that will not be dissipated. Even if we put off the power supply, the cables will have some charge due to high voltage. So better to put the red tag. That will be an extra safety. So now main switchboards having safety devices like as we saw, fuse, circuit breaker, reverse power relay, preferential trip, under voltage relay, overload trip, low frequency trip. So these are all devices which is present in the main switchboard, which will be between the generator and the bus bar. So next is What is reverse power relay? So reverse power relay is a directional protective relay that prevents the reverse power flow. The relay monitors the generator output. If the output falls, the generator will act as a motor and starts to take power from the bus bar. So further, to avoid the power failure or the supply demand, the relay senses the reverse power and disconnects the generator to avoid any further mechanical damage. See, this is an engine from the diagram. Can be a prime mover or a turbine which is connected to the generator. So generator is producing some kilowatts of power and that is connected to the main bus bar. Now, what is happening? When the engine is giving some torque to the generator, the engine mechanical torque is given to the generator. The generator has to run with the main torque, and some losses of torque will be also there, that is friction losses will be there, and magnetizing current, due to magnetizing current, magnetizing torque will be there. So when the generator is providing power supply to the main bus bar, that we can meet the demand. Suppose if the generator cannot give the power supply to the bus bar because of the main torque is becoming less than the friction losses torque. So if it is becoming less, it starts to take power from the bus bar. Instead of providing power to the bus bar, it starts to take the power from the bus bar and it will act like a motor. So this may happen due to paralleling of generator. This is already running generator. Suppose we can parallel one more generator to this line. So during this paralleling of generator also, this type of reverse power may occur because of unmatching of certain things. So that what are the reasons why this reverse power is taking place? What is the reason that has to be seen? So the reverse power has to be immediately deducted and it has to disconnect the generator. Otherwise, the ship may go for the full blackout condition. The full power failure may happen and the shutdown of the ship may happen. So before that, we have to know what is the cause and we have to get the remedy for that, and the reverse power relay has to be activated. So now, and the prime mover not supplying sufficient torque to the generator. As a prime mover engine, maybe the engine is having low lube oil, maybe some of the excitation, loss of excitation of the alternator, governor, faulty condition of the governor of the prime mover. So this may be the reason why the engine cannot give the sufficient mechanical torque to the generator. Maybe lube oil, where fuel is very less, faulty governor, excitation loss. So this may be the reason why the engine cannot give the mechanical torque to the generator. And the generator producing the main torque will be less when the mechanical torque is less. So when the main torque is less than the losses, automatically the generator cannot provide the power. It starts to take the power from the bus bar. So it will act like a motor. Motoring action will start and it will consume the power from the main bus bar. So this will meet a high demand for the power supply and the whole system may go for the blackout condition. And during the fault, synchronization. So synchronization is nothing but paralleling of two generators. So why paralleling is done? That is due to some more power supply is required. Demand is more. On board ship, the demand will be more at the time of tank cleaning, at the time of cargo loading and discharging condition. We need more power supply. More deck cranes will be running and motors will be running for cleaning purpose and other things. So we need more supply. So at that condition, the synchronization is done. So while we do the synchronization, we have to check the three important factors, which is phase sequence. We have to check the voltage ratings. We have to check the frequency. If these three matches between the running generator and the incoming generator, then we will do the synchronization. Otherwise, we cannot do the synchronization. So this synchronization can be done by methods like synchroscope method, dark lamp method, bright lamp method, and voltmeter method. In the synchroscope method, so the synchroscope will rotate slowly clockwise. So we can take like 5 to 7 seconds per revolution. So at the 12 o'clock position, the synchroscope, the indication of the 12 o'clock position in the synchroscope, usually we say that the breaker is closed. This is our theory, but practically due to the human response time, lagging of human response time, we start to close the breaker after the 11 o'clock position. So this is a synchroscope method. After checking the 3 parameters like voltage, rating, phase sequence, and frequency. And next is dark lamp method. 2 lamps will be connected to the same phase of the incoming generator and the bus bar. The flickering of the lamps are monitored. The flickering must be slow. And when both lamps are dark, ACB is closed. So there is a dark lamp method, then bright lamp method, then voltmeter method. So suppose if it is 3 is mismatching, but the breaker is closed. At that condition, because of the low frequency also. So due to the low frequency, the generator cannot produce enough power to the bus bar, and that will also lead to the reverse power relay trip. So these are the reasons, the causes of the reverse power relay trip. When the prime mover not supplying sufficient torque to the generator, why the prime mover cannot supply? That is because of the low fuel, because of the faulty condition of the prime mover or excitation of the alternator loss. This may be the reason reverse power relay trip has happened. So we have different sensors and monitoring system to monitor. And this is working principle of reverse power relay. So this reverse power relay actually in AC, when the direction of the AC changing, is very difficult to find out and deduct in AC. When the direction is changing, it is very difficult to find out. So this is a reverse power relay diagram. Actually, we have a lightweight non-magnetic aluminum disc. So this is called aluminum disc. This is lightweight non-magnetic disc which is placed in the soft magnetic between the soft laminated iron core electromagnets. So topmost we have one iron core magnet, and down below we have an iron core magnet. In between we have this aluminum disc. So the upper coil is having more number of turns. So the induced current which is produced, it will be more inductive. So the induced current which is produced will also lag by 90-degree angle. So there will be a positive lag. There will be a positive lag of 90-degree. So because they design it with more number of turns, more inductive, so the inductive current produced will be lag of 90-degree. So the lower coil is current coil. So that is having less number of turns, that is less inductive, and that is produced with lagging less as compared to the upper coil. So this induced current in the coil will produce the magnetic magnetic flux is produced. So that is the magnetic flux will link through the disc, and this will produce an eddy current in the disc. So this eddy current will generate a torque, and the disc starts to rotate. The disc starts to rotate, and this is a stopper button that will stop, and that is not allowing to connect with the trip circuit. So when it is in normal rotation. So when the reverse power acts, so that is when the reverse current formed. So in the PT coil and the CT coil, that is potential transformer and the current transformer. So what will happen at that condition? Start to rotate in the anti-clockwise direction. The stopper will now move, and this will get towards to the trip circuit, and the circuit is get tripped. So this is the working principle of the reverse power relay trip. There is a non-magnetic aluminum disc is placed in between the soft core laminated iron core electromagnets. and the top potential transformer coil is having more number of turns, so more induced current is produced, and that is lagging by inductive, due to inductive, that is lagging by 90 degree, and down current transformer will produce less, but the magnetic induced, the magnetic coil flux which is produced will be more in current coil as compared to the top. So because of this, the aluminum disc will get an eddy current, and the eddy current will drive a torque, and that is used to rotate the disc. The disc will rotate normally, and when there is a reverse current, it will start to rotate in anti-clockwise direction, and the stopper, this is the stopper button, so the stopper will move, and now the stopper is moving, it is released, and it is getting towards your trip circuit. So this is the simple working principle of the reverse power relay. So what is the advantages of reverse power relay trip? So when the trip happens, it prevents the blackout in the ship, and it prevents the damage to the generator stator, because the stator starts to take the power and it acts like a motor. Stator will start to take the power and it will act like a motor. So the prime mover, turbines, and these things are avoided from the damage. To prevent fire or explosion that may be caused by unburnt fuel in the generator. It is also preventing fire or explosion. It prevents overloading the power supply. It prevents total blackout or preferential trip. So these are the advantages due to reverse power relay trip. So prevent the damages to the generator, prevent the damages to the prime mover, turbine. So it can also prevent the fire or explosion that may be caused by unburnt fuel in the generator, and prevents the overloading of the power supply. So it prevents the total blackout, so which is very important. We have some of the loads, steering gear, alarm system, control systems, fire extinguisher, so GPRS systems and other systems, which is very much important to be always, navigation lights, all coming under the essential services that has to be present always. The ship cannot be in fully blackout condition. So that is helping by this reverse power relay trip. So next is preferential trip and overload trip. So whenever the generator is getting overloaded, the preferential trip will operate, and that will give alarm as well as it disconnects the non-essential loads. So the preferential trip is, if it is not installed during the generator overloading condition, the overload trip will get activated, so resulting to total power failure. So when the overload trip is activated, it will be total failure, total shutdown to the ship. So the preferential trip is activated, then it will connect to the essential loads. The non-essential loads are disconnected. So to make generator to be operated continuously, the preferential trip relay will operate and disconnects the non-essential loads. So these trips are installed between generator and bus bar. So the overload trip relay is set at 150% of the current at 20 seconds time delay. And the preferential relay trip is set at 110% of the current at instantaneous trip. Immediately it will strip. So that is the 110% of the current value. So if that current value is present, then the preferential relay will trip. The electromagnetic coil is kept. So that coil, if it is sensing more than 110% of the current, then it will be an instantaneous trip. So that is PRT. So the overloading trip is set at 150% of the current. That trip will be at 20 seconds if a time delay is kept. So time delay is, sometimes there may be a sudden surge of voltage, and that may be all right within some seconds. So we do not know what is the exact condition. So that may be for some seconds and it may be all right. So time delay is kept, dashboard is connected. And this is non-essential trip order most of the ship. So in most of the ship, so within 5 seconds, air condition and ventilation will get tripped. And within 10 seconds, refrigerated cargo plant trips. And within 15 seconds, whatever the deck equipments, so that deck equipments will get tripped. So this is the working principle of the preferential trip. So here the load current passes through this electromagnetic coil, and by the spring action with the relay movement, the spring movement, the trip is activated. So when it goes more than a particular limit of the current, the spring will move because of the action of the spring. It is getting attracted towards the trip circuit. So in each 5 seconds, air condition will get tripped, and 10 seconds refrigeration, and 15 seconds it will be deck equipments. So that is dash point is provided to as a time delay. So this is a cylinder. The structure here which is shown is a cylinder which is having a silicon liquid, and a piston is kept. So that is for the time delay. So according to that movement of the liquid, the piston movement, 5 seconds, 10 seconds, 15 seconds delay, the non-essential trips are removed. So the essential trips, essential equipments will be provided per supply. So when under the overloaded condition, unwanted non-essential, that is non-essential trips will be removed. Air condition is not required for all the time, so we can remove it. But what is more important, steering gear is important, alarm system, control system, fire monitoring, and fire alarms and fire extinguishers. These things are navigation aids, whatever the navigation lighting systems, radar system, GPRS systems. These are all very important to be always present with the power supply. So when navigation lights are not there, the ship may go for collision. So this has to be avoided, and the full shutdown should not happen in the ship. So we need the power supply for the essential preferential loads, which is always required to for sustaining the sailing. So this is about the preferential trip, working of the preferential trip. Thank you for listening.